Okay, hello, and welcome again to the University of Maryland Extension's Zooming into Healthy Horsekeeping 2020 webinar series. We're excited to have those of you that are joining us live and for those that might be listening in later on the recording. My name is Jennifer Reynolds. I'm the Extension Activity Coordinator for Equine and Poultry Programs at the University of Maryland. I will be assisting as host today, and it is my pleasure to introduce our speaker, Andy Ness. Andy is the agriculture educator in Harford County, and as a native of Harford County, he attended the University of Delaware, where he received his bachelor's degree in plant sciences and then a master's in plant pathology. One of his main focuses as an extension educator here at Maryland is working with livestock producers and improving performance of pastures and forages. So we're very excited to have him with us, and he will be presenting the topic of interpreting soil test reports, what you need to know to maximize pasture performance.
All right, thank you, Jen. Can you hear me, Jen or Erica?
Yes, we can hear you. You're good.
Okay, perfect. All right, well, thank you, Jen, for that introduction. And thank you to everybody who's joining in on our webinar here today. So just as a little bit of a disclaimer to start, as you can see from my introduction, I am not a horse or equine person at all. As far as I venture into the equine world as it relates to pastures and forages. So that's why I'm here today. But I will say that, you know, as far as pastures go, really your starting point really should be soils and soil testing. So my objectives for us today, I don't want to drown you with a lot of technical information and chemistry and all that boring stuff, but I do want to get across a couple of good points as they relate to soil testing. We're going to walk through a basic soil test and an analysis, and by the end of that, hopefully you'll understand what each and every one of the parts mean on your report, and then how to interpret that to make better management decisions for your pastures. All right. As was mentioned earlier, if you guys have questions, please use the chat box and Erica can wrangle them for us and I will try to address them to the best of my ability. All right, let's see if I can get Zoom to work here. Okay, so why do we soil test? Well, there's some obvious implications here. Number one is to make better management decisions. So, you know, what type of forage or plant should I put in a specific soil type? It's going to also give us information about inputs, so that would be fertilizer and lime. It can also be a good starting point for troubleshooting a problem that you might have. So maybe you have a really poor performing pasture or a poor performing part of a pasture. One of the first things to solving that would be to try and troubleshoot and make sure your soils aren't out of whack. Third, it would be to obviously improve profit. This can be, you know, in the horse world, maybe it's saving us money by optimizing the fertility and pH levels of your soil. And then the other factor here is also going to be to track your soil properties over time. So keeping good records and looking back, you know, 2, 3, 4, 5 years or even more, and seeing where your physical and chemical properties are heading in your soil, and that can help you make better decisions as to how you're going to manage it moving forward. So what I'm going to do today is I'm going to go through a soil report. This is just one example here. This is not an endorsement of Waypoint Labs. This is just what I had on hand to use as an example. Now, depending on the lab that you send your soils to, you're going to get a report that, you know, looks different. Every lab uses a different layout, but more or less they all have the same information on it if it's a basic soil test that you had done. So even if the report isn't laid out like this, more or less you're going to find all the same information on it. So what I'm going to do is I'm going to break this down, and we're going to talk about pretty much each one of these columns and what they mean and how to interpret what's in those columns. So the very first thing that I look at when I read a soil test report is pH. That is what I'm most interested in, more or less, is what is the pH of this soil? And the reason why that's important, I'll discuss later, but most of you probably already know. So if you look at this report from Waypoint Labs, you'll see a column called pH, and under that, they divide it into two subcolumns. The one on the left says soil pH, and the one on the right says buffer index. Sometimes buffer index, other labs will call buffer pH. So the important thing to realize here is the one that says soil pH or pH, so the one on the left-hand column in this example, that is the actual pH of your soil, right? So whatever that number is there, that's the pH of your soil. The number next to it, which in this case is buffer index or buffer pH on other reports, this refers to what we call reserve acidity in the soil. And what reserve acidity is and why it's important is because that will affect your liming rate. If your soil needs lime to bring that pH up, buffer index is going to be really important to determine that liming rate. So let me explain that a little bit more here. So in your soils, basically, you have two pools of hydrogen ions. Hydrogen ions is just all that is what we're measuring when we measure pH. It's just the concentration of hydrogen ions. So the more hydrogen you have in that soil, the lower your pH. So it's going to be more acidic. So when we measure soil pH, what we're really measuring is what's on the right-hand side. So that's the hydrogen ions that are floating around in the soil solution. So just the soil water. That's your soil pH. That's what is influencing the availability of nutrients in your soil. That's what we're really concerned about. Now, that's not all of the hydrogen ions that are in your soil. There's actually another, which can be a very large pool of ions that are trapped in clays and organic matter in your soil. And we call that reserve acidity. So that would be the big bubble on the left. So what happens is when your soil pH gets too low, so it's too acidic, we're interested in liming it to neutralize some of that acidity. So basically what we're doing is that liming material is reacting with the hydrogen ions in the soil water and pulls them out of solution. All right, and when that does that, you reduce the concentration of the hydrogen ions, which then that's what is going to increase your soil pH. So it gets it closer to an ideal level. Now, soils are always, this is a biological system, and biological systems like to reach sort of an equilibrium. So what's going to happen is if we pull those ions out of solution, what's going to happen is other ions that were maybe trapped on clay surfaces or in that organic matter are then going to be released and go back into the soil solution water. And then, as you can see, you're going to have more hydrogen ions in that soil solution water, which is then going to further acidify your soil solution, your soil pH. So basically what we have is some soils have a really good ability to basically buffer liming materials that you add to them. So back to this example here, if we look at the different soil tests here, so there, in this example, there's 5 different samples that were submitted to the lab. Okay, so on the left-hand side is our soil pH, again. And then on the right-hand side, we have the buffer index. Okay, so what we need to know is basically the closer the number is to your actual soil pH, then that means your soil is considered highly buffered or it has a lot of reserve acidity. So what that means is that it's going to require more liming material in order to bring the pH up to a sufficient level. Okay, so if we look at these two soil samples here, the one on the top, it has a soil pH of 6.9 and a buffer pH of 7.9. And then if we look at the one on the bottom, we have a soil pH of 6.9 and a buffer pH of 7. So what that tells me is that the soil sample in the bottom is going to require a lot more lime in order to bring it up to a sufficient level, because it's more highly buffered, because those two numbers are closer together. So if you ever looked at a soil report and you had, say for example, you had two soils, they were both at pH 5.5, and you look at the recommendations sheet, and maybe one soil will require 1.5 tons of lime to bring it up to a target pH of 6.5, for example. And maybe the other soil will have a recommendation of 2.5 tons of lime. And you might be wondering why in the world is there such a discrepancy in the liming recommendation? Well, it's because of this buffer index. The one that's requiring more lime is more highly buffered. Okay, so this is just all kind of stuff that the lab does in the background, and this is how they calculate your liming rate for your soils. Sometimes you won't get a buffer index or a buffer pH for your sample, and that's just because your soil would already be falling in that ideal range, pH range between 6 and 7. So actually in this example here that I pulled up, really the only sample that had a buffer index was sample number 2, because it was out of that range between 6 and 7. The others wouldn't be reported as a buffer index because they had sufficient pH to begin with. So that is the nuts and bolts of soil pH and buffer pH. Just remember, if there's a little change between soil pH and buffer pH, that means your soil is highly buffered, and that soil is gonna require more lime to bring it up to sufficient pH levels. All right. So the next thing that I look at in a soil report is organic matter and cation exchange capacity. So I'm gonna pull those out off to the side on this report and look at them together. And I'm gonna talk about them together because they're sort of related. So your organic matter, that's abbreviated OM in this report. This is the organic component of the soil. Okay, so it's typically reported as a percentage of your soil. Okay, so these are all as percentages. Soil organic matter is a good property to know and monitor, because you would like to have more soil organic matter. The more the better in general, because soil organic matter plays a huge role in chemical properties and physical properties of your soil. The more organic matter you have, you're going to have better nutrient cycling, you're going to have better water infiltration, you're going to have better soil structure, you're going to have a better ability of your nutrients to hold on, and stay in the soil rather than running off or down into groundwater. So all those are good things to have. So for our soils here in the Mid-Atlantic region, if you have an organic matter percentage, up above 4%, 3, 4, 5, 6%, you're doing pretty well. Our soils tend not to be super high in organic matter here, just because our soils aren't formed, the parent material that our soils are formed under are not conducive for high organic matter. But you can manage that, and the ways to increase organic matter is going to be adding in things like manures and compost, reducing tillage. Now, obviously, that would be you're not going to be tilling up your pastures that much, but more frequent tillage tends to burn organic matter, so it would lower it. So no-till practices really help build organic matter. The second column there, the one on the right, is CEC. So that stands for cation exchange capacity. And all that means is it's the soil's ability to retain positively charged ions. And those positively charged ions in chemistry are called cations. Basically what these are, you can think about them as parking spaces on your soil. Now these parking spaces can be used to park things like fertilizer, nutrients that your plants need. Okay, so the more parking spaces you have, the more nutrients your soil can hold on to. Again, so that's a good thing. And Where do these parking spaces come from? Well, they come predominantly from two sources. One is going to be on our organic matter sites. So that's why sort of organic matter and CEC are closely related and connected. But they're also going to come from clays. So soils that tend to be high in clay and or organic matter tend to have higher cation exchange capacities. So cation exchange capacity is measured in milliequivalents per 100 grams of soil. Basically, all that means is, you know, the higher the number, you have more parking spaces. Okay, so that's really what you're interested in. And again, for our soils here in the Mid-Atlantic region, if we're working with kind of exchange capacities north of, you know, 5 and up into the double digits, 10 or so, we're doing pretty good. Okay. Another 2 points and just some tricks and backhand the calculations is for cation exchange capacity, what you can do is multiply that number by 10, basically just move the decimal point right. That will equal roughly the amount of nitrogen that your soil can hold at any one time. Okay, so if we look at that first example in that soil there, it has 5.6 milliequivalents per 100 gram for CEC. What that translates into is about 56 pounds of nitrogen that soil can hold without it really washing away at any one time. The reason that's interesting to know, and you know, from a management decision, is if you're top dressing your pastures with a nitrogen source, it can be nice to know that, you know, roughly how many pounds can you hold without really losing it or having it subjected to loss. So if I was, you know, treating this pasture with nitrogen, you know, I might look at using, you know, between 50 and 70 pounds or so of nitrogen in one application, okay, rather than putting on, say, 200 pounds where it would be subject to a lot of it running off or being lost. The other rough calculation is based on organic matter, and roughly 10 to 60 pounds of nitrogen will be released out of that organic matter just through natural cycles for every 1% of organic matter, okay? And that's a rough estimate. It depends, it's heavily influenced on the weather that we have because this is a biological process. So years where we have, you know, really cold springs, for example, and a lot of rain, you're gonna be closer to that 10 pounds. Whereas if we have ideal soil moisture and temperatures are warmer, you're looking at, you know, closer to that 50 or 60 pounds of nitrogen. Let's see. All right. So the next sort of block of information that I like to look at is called base saturation. In this report from Waypoint, it's on the lower left. Okay, so base saturation is related to what we just talked about when we talked about CEC. So base saturation is the percentage of your cation exchange sites that are occupied by basic cations. So what are these basic cations that we're talking about? Well, that's potassium, magnesium, calcium, sodium, and hydrogen. All right, so how much are in these parking spaces, okay? They will always sum to 100%, okay? So all labs report potassium, magnesium, calcium. Some labs choose to report hydrogen and some don't, but you could easily figure out what it is just by adding the others up and subtracting by 100, okay? Now, there are some sort of, I put ideal in quotes, ideal ranges that you want to be in for crop production as far as it's related to base saturation. So for potassium, I like to see you be somewhere in the 3 to 5% range. For magnesium, that's Mg, somewhere in the 10 to 15%. Calcium, Ca, that's the one that you're going to want basically the most of your site's occupied by, somewhere 50 to 80%. Na is sodium, and sodium is salt. So sodium is a plant essential nutrient. However, if we get too much of it, obviously that's a bad thing. It is a salt. So we like that to be under 2%. And then H is hydrogen, okay? And we'd like to have that under 10%. If you get your pH out of whack, so if your soils start to get really acidic, you're gonna start to see hydrogen creep up over that 10%. It's probably gonna be closer to 20, okay? Other things to look at are gonna be your magnesium to calcium ratio there. Sometimes I'll see magnesium get over 20% or so. The reason being is dolomitic limestone or high mag lime is typically cheaper than calcitic limestone. So over time, if you keep liming with magnesium carbonate rather than calcium carbonate, you can start to build up your magnesium too much. So those are some things to keep an eye on and to try and sort of stay in those rough parameters necessary for crop production. The reason it's important to have those ratios somewhat close is because plants, that they don't really have a huge amount of discrepancy with what they can pick up in the soil. Basically, if it's there, they can pick it up. So if the ratios get too far to one side, basically they're getting too much of one thing and not enough of the other.
Okay, Amy, we can ask your question. The question is, how long does the CEC hold nitrogen, and what length of time between those nitrogen applications?
Okay, so good questions. So for, let's see. So as far as how long can your soil hold on to nitrogen, that's a really kind of ambiguous area. The nitrogen cycle is crazy. So nitrogen goes through a lot of different transformations, and really it has several different opportunities to be lost. So it's either going to be lost through runoff, or it can be lost through leaching down through the soil profile. It can also turn into a gas very easily and be emitted through volatilization. It can also be bound up in organic matter and unavailable to your plant. So it goes through a lot of different cycles, and it really does depend on the weather. All right. So if we have a really wet season, a lot of rains that are leaching down through the soil profile, you're going to lose a lot of nitrogen just because it's moving down through the plant root zone and then out into subsurface water and things like that. So really, basically, when I say at any one time, really what I'm thinking about here is thinking about seasons and management. So, think about, early spring, late spring, and then summer, late summer, and fall, basically, is kind of the 4 different seasons that I like to think about in pasture management. And then what was the second part of the question?
What is the length of time between the nitrogen applications? So she had also asked earlier, pastures established in the falls that have had half of the fertilizer applied, when seeded, what should the application look like next year? Split 50-50, spring, fall, or 75-25?
Okay, so if we're talking about a cool season grass pasture, which is typically what we have here, really are really important management times as far as fertilizing, especially when it comes to nitrogen, is going to be your late summer and fall applications. Okay, so that's going to be your most important application of fertilizer, because what those plants are doing then is they're setting themselves up for next year. So you really want to feed those plants to make really strong, healthy roots and reserves so that the following spring they can come out and push a really big flush of vegetative material. And that's what we're shooting for. So my answer to that is really follow the recommendations that are on the soil report or that are in your nutrient management plan. Okay, so, but if money's a tight thing and maybe you're trying to figure out where your best timing is going to be, for sure, the fall fertility is going to be your most important. All right. I don't know if that completely answered your question. If not, feel free to keep asking and we'll revisit that later on in the presentation. Okay. All right, so I'm gonna move on. Again, guys, if you have questions, please keep typing away. All right, let's see if I can advance the slide. Okay, so the next section that I like to look at is basically your nutrient levels in the soil. In this report, it's sort of the center section. A couple of things to realize here. I'm going to move from left to right. So the very first column on that left-hand side, you'll see ENR, and this is reported in pounds per acre. And what this is an estimation of the nitrogen that will be released from your organic matter over the course of a growing season. Now, there's no real calculation for this other than sort of what I told you before, the sort of 1 to 60 pounds per percentage. Each lab uses a different calculation, and I'm sure they even use some modeling with weather and things like that to come up with this number. But basically what it is telling you roughly for that first soil, you can expect about 118 pounds of nitrogen to be released over that course of that growing season. All right. Now, if it turns really dry and hot, that number is probably going to be really low. If it gets really wet and cold, or that number is probably going to be really low too. So it's all based on ideal conditions for that number to be realized. Again, it's kind of a interesting number to know as you're looking forward into how much fertilizer and things to add to your soil. Now, the next one on the right-hand side, or the next one to the right, is going to be your phosphorus recommendation or your phosphorus levels. You'll see it says M3 at the top. That's just the extraction method that the lab used for the phosphorus extraction. M3 stands for Malic 3, which is a standard and accepted extraction method for our soil types here. So this number is reported in parts per million. Okay, so you can see that first one is going to be 40 parts per million of phosphorus in the soil. You also see a letter next to it, M. What this is the lab puts basically a scale they attach to it. So M is medium, so that's medium fertility for phosphorus, what they would consider. The next one is 27. They consider that low, so that's L. All right. You would also have high, very high, depending on the lab. Also, you also have underneath of that, MD equals 46. So what they did here is the lab went ahead and made a conversion to Maryland Fertility Index value. Basically what that is it standardizes all of your nutrient levels into a scale where if you're under 50, you're considered to be deficient in a nutrient. If you're between 50 and 100, you're considered in that optimum range. If you're over 100, you're considered to be high. And if you're over 150, you're considered to be very high. So that just puts it into a scale. That way you can, it's also used in Maryland nutrient management planning as well. All right.
Good. Okay, another question. I'm Pennsylvania. PSU soil test says 2,000 pounds per acre. When should lime be applied? It's a grass field which they plan to fence and pasture for horses.
Okay, so good question related to liming. So again, follow your soil recommendation as to the rate. So if PSU says 2,000 pounds to the acre, that's good. You can apply lime at really any time in the year. Lime is typically applied in the fall or the spring. Keep in mind that lime is a slow reacting material. So when you put it out there, it's not going to really have that much of an effect, if any, until about 4 to 6 months or a year out. Depending on how fine that material is or how coarse it is, that's going to affect how quickly it will react in your soil. So the finer the lime is, the quicker it will react, and the more coarse it is, the slower it will react. Personally, I think fall applications are good because that'll set your plants up for a good flush in the spring and to get things ready to go for the next year. So really looking at when you can get out there and when the soil is fit would be the best time to really do it. All right. So I don't see another question in the chat box, so I will move on. So let's continue on with these nutrient levels here. So we talked about phosphorus. Now the next nutrients elements that are reported are in potassium, magnesium, calcium, and sodium. And again, these are all reported in parts per million, and they all have a letter attached to them giving you some sort of indication as to whether they're high, medium, or low in your soils. All right. So another rough calculation, if you were just ever interested, is since the nutrient levels are reported in parts per million, what you can do is you can multiply that number by 2, and that will equal pounds per acre. All right, so for that first soil, for example, for phosphorus, it's 40 parts per million. You multiply that by 2, it's 80. So that soil roughly has 80 pounds of phosphorus in it per acre, okay? The reason that calculation works is because basically a soil sample is taken between 6 and 8 inches. In that 6 to 8 inch slice of soil over an acre weighs 2 million pounds. So roughly, if you take parts per million, multiply by 2, that comes out to be pounds per acre. Right?
Okay, so back to the lime. Any thoughts on the pelleted lime as it is so much more expensive?
So I can't say for certain why it's more expensive, but I do speculate that it does take a little bit of more processing to get the lime into a pelletized form. And secondly, pelletized lime tends to spread a lot easier and better than pulverized or granular powdered lime. So you get a better product that's easier to handle and spread. So that would be a more premium product. So, all right. So I will move to the next slide. Now this is just sort of more of the same stuff. If we look at the bottom part of this sheet in Waypoint's report, you get more nutrient levels reported. Now these are more micronutrients, looking at sulfur, zinc, manganese, iron, and copper, and boron. Now, they can be interesting to know. Now your plants don't need these nutrients in great quantities. However, if you're trying to troubleshoot some nutrient deficiencies and things like that, these can be some interesting ones to look at, just to make sure there's nothing off there. You'll also see a column there for nitrate, nitrogen in the soil. You're not going to get that number unless you request a certain test from the lab. And really, it's not recommended to really even get that number because, again, nitrogen is so nebulous. It changes form. 1 minute it's here, the next minute it's in a different form. Really, that number is for more agronomic type crops rather than pasture. All right. So I want to make a couple of points here about management. So first and foremost is going to be follow the recommendations from the lab. And if you're in Maryland and you have a Maryland nutrient management plan, follow the management recommendations in that plan. All right. So as far as how much to apply and when, that's what you're going to want to go off of. Now that's assuming you took a really good soil test and submitted it to get the recommendations. We'll talk more about sampling here in a minute. And I can't stress this enough. So if you're in a situation where you need some work done on your pastures, maybe you're really deficient in a lot of nutrients and maybe your pH is really off, you have a really acidic pasture, where I would put my money first is invest in fixing the pH first. Because if your pH is wrong, it doesn't matter how much money you throw at it in terms of fertilizer or herbicides to manage weeds or whatever you're doing. If the pH is wrong, the pasture grasses and legumes that you're trying to grow are just not going to survive. So it's not even worth doing anything else. So soil pH is very important. Reason it's important is illustrated in this graph here, and I like this graph. So pH affects the availability of nutrients to the plant, okay, in the soil. So you can see here across the top, you have a pH scale, okay, across the bottom. You can see the scale goes from 4 to 10. And in the graph, you can see all these different essential plant nutrients. And green is high availability, yellow is sort of medium availability, and red and orange are low availability. And you can see how different nutrients become more or less available depending on where the soil pH is. The reason this is because there's a lot of chemistry going on here, and a lot of these nutrients can be bound in the soil by other things and taken out of solution and such. So really what we're trying to aim for is to get a pH, if I can get my pointer here. If we really want to get a pH somewhere in that 6 to 7 range. That's considered ideal for most of the plants that we're trying to grow in agriculture. And you can see in that range, pretty much everything is at least at a medium availability to the plant. And that's what we're after, okay? If you start getting pHs above 7, you start to really get deficiencies in things like iron and manganese, boron, copper, zinc. And if you get too low in pH, so if the soil gets below that 6 mark, you're really going to start to see a lot of deficiencies in other elements, maybe nitrogen, certainly phosphorus, potassium, sulfur, calcium, and those guys there. And also what this graph doesn't show, and I wish it did, but as you get lower and lower in pH, so more acidic, aluminum becomes highly available to the plants. Now, aluminum is not an essential nutrient for plants, and as a matter of fact, it's extremely toxic to plants. So if you start getting your pH lower than 5.5 into 5, aluminum really becomes very available, and it's highly toxic to your plant roots. The roots will die back. They'll actively avoid it, so they won't grow deeper into the soil. So you can really run into a lot of issues with a really acidic soil just because aluminum toxicity.
Okay, so one more question from Mary. She said, or is asking, should you retest pH after liming? And if so, how long afterwards?
Yeah, so good question. So I would recommend that you do retest your soil after you lime. And I would do it about a year afterwards. So say, for example, you applied lime in the fall. I would wait until, late summer, early fall, take a soil sample, submit it to a lab, get the report back in, a week or two, and then look at where your pH is. And if you need more lime, then you could continue and add another round of lime based on the recommendations. That's always a good practice, especially if you require a lot of lime in your soil. It's it's better to do it in increments because you really don't want to overshoot it. It's better to do it in increments, say apply half the first year and then half the second year based off of a soil test. So that's a good way to do it. So I hope that you guys see here how important soil testing is, or pH is to your pastures and management of your plants. So again, you want to maintain somewhere between 6 and 7. That's going to be pretty, that's going to be sufficient for most of our pasture species that we're growing here in Maryland in the Mid-Atlantic region. Again, when you start to get below 6, that's when you're really going to start to think about liming. Most of our soils here are naturally acidic, so just over time, and it's basically the nitrogen cycle, your soil will become more acidic. It's just the way it is. Once you start to get down below 6, that's when you're really going to start to consider liming. One thing I want to mention about lime again is when to use high mag lime versus calcitic or high cal lime. And that's when you really need to refer back to your base saturation analysis and consider those sort of ideal ratios and percentages. So if we look at this guy here, the middle column, calcium, I'm seeing that basically all of these guys, except for that first sample, could really use an application of calcitic limestone or high cal lime versus high mag lime. And that'll help bring up that calcium base saturation to a little more acceptable level. And then it'll also bump down that magnesium ratio a little bit. So just some things to look after and keep in mind as you're moving forward with liming decisions. So in review, just to recap, so we talked about soil pH and buffer pH and what the differences are there. So remember that soil pH is the actual pH of your soil, and that buffer pH or buffer index is what the lab is using to calculate your liming rate. CEC and organic matter, that's going to relate to nutrient retention in your soils. So that's going to be some good numbers to know as far as retention of nutrients. Base saturation, again, related to cation exchange capacity. How much of those sites are occupied by those basic cations that we talked about? And keep in mind sort of those rough ideal percentages for where you want to be. Now let me talk briefly on soil sampling because I'm a firm believer that people don't take soil samples properly. So it is important to do this step right, because keep in mind that the data that you get back in that report is only as good as the sample that you send them. So if you really cut corners or really try to, just get in there and get out and do a sloppy job at taking a sample, you're not going to get good information back, and that's going to really convolute your problems moving forward. Now, typical soil sampling depth is about 6 inches, 6.5 inches. University of Maryland nutrient management recommendations are based on an 8-inch sample. So for your pastures, you can take that 8-inch sample for fertility and pH for both of those. I do recommend that if you're monitoring just pH in a pasture, it is a good idea to take a separate sample at 2 inches. Because again, this is a pasture, so we're not tilling or working anything in. So what we want to do is really get a snapshot of what the pH is in that first 2 inches of soil so that we're not over applying lime. So, so keep in mind moving forward, it's a good idea to take a full fertility sample at that 8 inches. And then ideally, a second sample at 2 inches would be just to monitor your pH. Now you can do that all at one time, or you can do it at separate times of the year, however you want to decide to monitor it. Now for consistency's sake, it is a good idea to always pull your soil samples at the same time, year after year. So if you are consistently sampling in the fall, or if you sample in the fall, it's a good idea moving forward to always sample in the fall because there will be some seasonal variability in nutrient levels and cycling and things like that. And you can take that out of your data by sampling at the same time each time. So that way you get a better comparison year to year. A second thing that I want to mention is the number of cores that you should take. So the number of, with your little soil probe, you want to take for each management unit, say maybe it's a pasture or a paddock, you want to pull at least 15 to 20 samples, those cores, and mix them really well in a bucket. And that would be what you would submit to the lab as a sample. You want to really make sure you get those 15 to 20. If you skimp out and maybe only do 5 or 10, I wouldn't feel that confident with the data that you're going to get back, okay? Because there's a lot of variability in that sample area, and what you're trying to do is get that to sort of average out and get a good overall snapshot of your management area, so your pasture. So I hope I didn't bore you guys too long or too much. I want to thank you guys for listening. If there's any more questions, I will take them. If there are any other questions later, maybe you think of something later, just my contact info is right there on the top of the screen. If you would like to reach out to me, I'd be happy to help you out.
Okay, so I have one question. Clay is asking, any thoughts on the Haney soil health test as an alternative to or complement to traditional soil testing?
So the Haney soil test, that's an interesting one. It's getting a lot of attention, especially recently and especially in sort of the pasture realm. I will say up front that the test really isn't vetted for our soils here. And it's there is some debate as to the usefulness of the data that you get out of it. So basically what the Haney soil test does is it basically measures respiration to try and get to put a number on the microbial load in your soil. So the more respiration should correlate maybe to more microbes in a healthier soil. Again, there are parts of the world where this test maybe has more application, but there is a lot of debate in the soils world as to how useful is the information here for the mid-Atlantic soils that we have. So in my personal opinion, I would much rather go with a standard traditional soil test that measure, with a Malic 3 extraction method to get a good handle on what your pH is and your nutrient levels are. You can also, look at soil organic matter. That can be a really good indication of biological activity in your soil is just your soil organic matter percentage. So if that's really high, that's good. If you want to do a Haney soil test as sort of a supplement and just kind of see how they compare, feel free to do that. But as far as making decisions off of the Haney test, right now we can't really make any useful recommendations off of that. Any more questions? That's a good.
Any more questions? I think you're good.
I think you've answered. Oh, look, here we've got another one.
One more. Should you do the 8-inch or 2-inch soil sample test if you're establishing a horse pasture from a former corn soybean field?
So good question. So if you're going for a straight establishment, take your full soil sample at 8 inches. The reason being is you're going to have an opportunity to work the ground. So take that 8-inch sample, and then if your soil requires lime, you can then spread it and work it in, with tillage. So that would be, good to do that 8-inch test. Once your pasture is established, moving forward, obviously you're not going to have the chance to till things in. So what would be better is to take a full sample at 6 or 8 inches for fertility monitoring. And then you can do that 2-inch sample maybe every other time you soil sample just to monitor your pH and to make sure you're not getting, too basic or too acidic in that top 2 inches or so. Okay, so I don't see any others in the chat box, Jen or Erica.
I don't see any. It looks like that might be wrapping it up for today. Thank you so much, Andy. That was a great, very informative webinar. We hope that all of you listening in found some valuable information and were able to get your questions answered. If you'd like to learn more about our upcoming webinars the rest of this month, please follow us on our Facebook page, Equine Studies at the University of Maryland. You're also welcome to check out the additional resources on our website, which is posted there on the slide for you. If you look under the resources tab, you'll find that we have a lot of links there in print publication form too that you might want to look at and read, especially concerning establishing pastures and managing them. If you like watching webinars on your own time from any location, we have quite a few now on our University of Maryland Horse Extension YouTube channel. We will be posting this webinar there as well. So please check those out and subscribe to our channel. And we thank you all for joining us today, and we look forward to having you back with us next week for our next presentation. Thank you so much.